Perfect. And I should share my screen in a second. There you go. Hello everyone, welcome. The title and the objective of this webinar is to discuss a very specific tool in supply chain, this ABC XYZ classification. Before jumping in the subject, I just would like to take a minute to introduce myself and a minute to introduce my colleague Stéphane Leclerc, who's just with us. And you can see his video just right next to me, maybe on the left, maybe on the right, maybe on the bottom, but he should be around. Hello, Stéphane. So just to introduce me in a minute, I simply like to say that I'm someone who's genuinely passionate about inventory optimization and demand forecasting. I'm writing about these two subjects. I'm teaching these two subjects. I'm coaching people. I'm training professionals. And I'm working with companies as a consultant, helping them to improve the process or to create new models. I also co-founded SKU Science, which is an online platform on demand forecasting, but more about this later. In general, if you have questions on one of these two subjects, demand forecasting, inventory optimization, feel free to reach out to me or add me on LinkedIn. I'm always very happy to discuss these two subjects. Voilà, I think that's it. These are my main clients from 2021. We'll see who I will be helping in 2022. So feel free to join this list. I would love to be working with you, of course. Let me give the virtual microphone to Stéphane so he can introduce himself as well. Stéphane, yeah.
Can you hear me?
Yeah.
Okay, so hello everyone, I'm Stéphane Leclerc, so I'm the CEO of SKU Science. I'm also a serial entrepreneur since I co-founded 3 software startups, including SKU Science. I have 14 years in total in startups, but I also work in large companies like Intel, which is a semiconductor company that you already know, and Motorola on Aero Electronics. So my background is mostly on the high-tech industry and software world. So that's it, Nicolas. You can move forward with the rest of the presentation.
Okay, so let's start with the real question that we want to tackle in this webinar. So as the title of the webinar, I put ABC XYZ, but ABC XYZ is just a tool. And before looking at a tool, I really like to understand what's the question that we try to answer. So let me try to show you the question I want to answer in this webinar. So as a demand planner or as the manager of a demand planning process, you have a limited amount of human resources that can work on your forecast, right? Maybe you're responsible for 1,000 SKU, 10,000 SKU, 100,000 SKUs, and you have a limited team. Of course, human cannot review 1,000 SKUs, right? You cannot do that every single week. So you need to focus your work and decide that, well, you need to work on a very specific set of items. So the real question is, which item should you review first? What are the most critical or important items that you should review first? Okay, this is the big question I'll try to answer now, mostly using ABC XYZ. But before moving there, it's, I think, very important that we understand this question. We want to focus our work because we basically cannot work on everything. Okay. So when I ask this question, which product should we review first when we work on demand forecasting? Basically, we can think about it, but 2 main ideas will pop up. First, we want to work on the most important product for our supply chain. I will not yet define what's an important product, but we do agree that if for some reason we define something as important, we should work on it first. Okay, so something is important, it should get priority. Then, this is demand forecasting. We want to create accuracy. We want to add accuracy compared to a baseline. You know that I'm a big fan of the concept of forecast value added. And we have with us today, Michael Gilliland, who coined the concept in the early 2000s in his book. So here we are all big fan of forecast value added. So what you want is that if you edit a product, you add value to this product. Okay. So 2 things: important product where you are likely to add values. Now, of course, what we want to do is to try to assess, okay, but what are these important products for which I can add value? One way to do that would be somehow to classify your product with important product on one side and not so important product on the other side. You also want to assess product for which your baseline forecast engine is doing a great job, assuming that, well, if your forecast engine is doing a great job, you don't need to edit this product. But also a product where you say, well, my forecast engine is not doing a great job, so I should maybe check that, okay? And this is how we go to this ABC XYZ metrics. So just as an example, if you have a product that's very high volume, high importance, but low forecastability, you would say, I need to work on this because my model and my past forecasts are really bad. And this is a very important item, so I should focus on this one. On the other side, if you have a product that you're really good at forecasting, your baseline forecast is really good at forecasting it, and it's not an important product, so you would be here at the bottom right, well, it's not something that's the priority, right? Okay, so important product where we are likely to add value. Now we get an issue. It's that actually it's not super clear yet for you, or maybe you have some ideas on what kind of metric should I use to decide what's important and what's not. See here, I noted importance, but how do we define and how do we measure product importance in the supply chain? On top of that, we have the same issue here with forecastability. How do I define this? How do I find product where I'm likely to add value? What kind of metric do I use to do that? And that's the big question. Before I move on, actually, I would like to ask you the question, what kind of information are you using yourself in ABC XYZ if you're using it right now? So it's an interactive slide. You can basically just connect on this address that I put here on top of the screen. If you click there, it's for free. You don't even need to log in. You can just click on any answer you want. Okay, by the way, there's an answer called I do not use ABC. Actually, 3 answers. So if you don't do that right now, feel free to just click on, well, I don't do that, which is fine. I'm not blaming anyone. And it's also a multi-selection. So if you use multiple things in ABC, you can click on multiple answers. That's quite interesting. So we have already 44 people who connected to the tool and already 20 answers. Let's just wait one more minute to see where we are going. So what's already interesting is that we see a big team of, we want to use historical volume, some of you in units, some of you in value. It seems to be 50-50, so that's quite interesting. There's a smaller team, or if we want to have the future forecast rather than historical volumes of sales. We have a big team for demand COV here as well. Historical forecast error that seems to be really low. And somehow, and I'm not surprised by calling this webinar ABC XYZ, there is no one who's not interested into it. I guess that's a very good survival bias example here. And a few of you want to try it out. Okay, interesting. So let me go back to my question. The question was, okay, we want to find important products and we want to find product where we are likely to add value, but what kind of metrics do we need to use to find this? Let me answer this question. So let's try out a few ID. It's the one where we would use historical volumes in units, or in value would be more or less the same, to assess the importance of a product. For me, historical volumes in units does not seem to be a good idea. Why? First, historical volumes, you're looking backward. And it's not because something was important in 2021 that it's very likely to be important in 2022 or in the next 3 months. Obviously, we can think about something with a trend. We can think about dying products that were kind of your top seller in 2021, but it's unlikely you're going to sell them in 2022 because they're going to be replaced by something else, right? All these products, it's not because you sold a lot last year, you're going to sell a lot in the next 3 months. Now, if you have seasonal products like ski, snowboards, tires, anything that's seasonal, your expected sales over the next 3 months, it's absolutely not correlated with the sales in the last 6 months, right? If it was the high season over the last 6 months, it's going to be the low season now. And if it was the low season in the last 6 months, it's going to be the high season now. So looking at historical sales will not tell you if this is going to be one of your main sellers in the next few months. On top of that, we have another issue. So some of you work in supply chain where most of the product have more or less the same kind of value. And I know that some other people work in supply chain where you have some very low value product and some very high value product. I always like to bring the example of selling hammers and nails. And basically the issue of using volumes in units is that you're not comparing apple to apple, right? So in terms of your volume, you would be selling a lot of nails, but it's not worth so much. And you're just selling a few hammers, but it's worth a lot. So actually, if you had to choose on which to focus, you should focus on forecasting hammers because the total value is higher, right? Now, if you use historical volumes in units, you're looking backwards and you're not putting your attention where the revenue, cost, and value is. So for me, it's a bad practice. Let me move to another idea for forecastability. I know a lot of people use demand COV. This COV is its coefficient of variation, and you compute it as the standard deviation of demand divided by the average demand, and you get a percentage. Now, I have a few issues with COV, and the main issue is that COV does not represent the forecasting difficulty or the forecastability, as I like to call it. Let me try to show you in the next 2 slides why COV is not a good indicator of forecastability, okay? And then I'll show you which one we should use instead, okay? Let me move on to just trying to prove and to show that COV is not a good indicator. So first, just a bit of math. How do we compute COV? So COV, you compute demand standard deviation. For example, you do that over 2021, and you divide this by the average demand in 2021. Okay, so I show you the math here on the bottom right of the screen. You see here, you see an example on a graph, and you see that's an example. Let's imagine for 2021, and we had the demand, an average demand of 5 pieces per month. We have a standard deviation of 2.22 pieces per month. Okay, so I get a COV of 44%. Now, I don't like COV for a few reasons, but first I would like to compare it to a forecasting benchmark. The more I work on demand forecast, the more I have to tell you the secret, I'm falling in love totally for forecasting benchmark like moving average. I think using forecasting benchmark will allow you to compare yourself to something standard and will allow to tell you if you add value or not. It's the same for COV. So instead of a COV, I would always advise you, and you will see why, to use a forecasting benchmark. So here on the screen, you see the graph of this moving average in green, and I'm computing this historical root mean square error of this moving average. Basically, I'm not going to go into detail of forecasting KPI. You know, I love the subject, but that's not the point today. RMSE, it's, let's just say, similar as COV on this kind of data set. Okay, let's just put this aside and just assume it's the case. So we see here that COV is slightly better than this forecasting benchmark. Basically, what's happening here is that COV benefits from data leakage. It's a data science term that basically says that when you compute the COV of 2021, it's basically assuming you already know the demand average of 2021, which is not a forecasting thing. No one's going to ask you to do a forecast for 2022 for one of your products, given the fact that you know the average sales in 2022. That simply does not happen. You never do such kind of a thing. When you use a forecasting benchmark like a moving average, you take the average of 3 months to forecast the next month. You have no data leakage. You never see the future. Whereas when you do COV, you take the whole demand of 2021 and then you compare it to the mean of 2021. So basically, it's like forecasting in the past. It's much easier. So COV gets basically an advantage over any other technique. And that's why COV, it's not a forecasting technique, because it's basically making a forecast knowing already the future. But it gets worse. COV can actually deal with trends and seasonality. You see here that if I put a trend, you see COV, it's always looking at the difference compared to the mean. And we see here that the moving average is doing quite a great job, even though it's just a moving average. Whereas COV, it doesn't make so much sense to compare this blue demand with this orange average, right? And you see that the difference to the average is kind of growing over time because of this trend. And it makes no sense. It's even worse with seasonality. So if you have a seasonal product and you're looking at daily sales over the week, if I do a simple seasonal moving average, it's just like averaging the last 3 Mondays to predict the sales of next week, Monday. Nothing fancy really. this seasonal moving average is doing a great job, where COV again is failing at this, because COV is just drawing a flat line and it makes no sense. Okay, so COV cannot really cope with trend and seasonality, and I would simply conclude that it's not a good idea to use COV to assess forecastability. So remember, COV is not a forecasting technique. COV cannot cope with trend. COV cannot cope with seasonality. So COV is not a tool that's basically adapted to supply chain. Okay. Let me move on, because now I looked at bad practices for ABC XYZ. Now I would like to show you some solution. So let's go back to this status here, and we ask ourselves the question, okay, we need to look at importance, we need to look at forecastability. What metrics should we use? First metric, so in terms of importance, how do we assess the importance of a product? We should use what I like to call value-weighted future forecast. So as said, we don't want to be backward-looking, we want to be future-looking. We want to assess what is going to be important in the next 3 months, in the next 6 months. We don't want to know what was important the last 6 months. We want to be forward-looking, okay? And also in terms of importance, what we want to do is to take into account the value of product. Remember, you don't want to spend time forecasting nails, you want to spend time forecasting hammers. So you need to weight the forecast by the value, okay? Now, in terms of forecastability, I think the easiest is actually to look at the historical forecast error you had on each item and then to classify them based on what was your baseline forecast error. You can imagine that you have a very good forecasting engine that's really good at forecasting seasonal product. So actually, you don't need to focus on seasonal product. Now, if you were using COV will flag every seasonal product as difficult. You don't want this. You just want to spend time on products for which your tool is really doing a bad job. The idea, again, is that if your baseline forecast is quite bad for some product, these are typically the kind of product where us, as human, we can add value. Okay, I will move on up to the next point. So let me recap. We are demand planners, or we are the manager, we are managing a demand planning process, and we want to help our team, or we want for ourselves to look at the most important product, because we cannot review the whole portfolio of tens of thousands of SKU, and we want to focus our time on the very most important product. Okay, that's what we wanted to do. We looked first at ABC XYZ, saying, well, if we look at historical sales and COV, it might not work. But if we look at the future forecast by value and historical forecast error, then this tool, ABC XYZ, is really going to point us at the right product. Now, actually, we can go further. Let's see that this slide is called and beyond. Actually, ABC XYZ, it's limited. First thing, the great thing about it is it's a simple tool. It's a simplification tool. It's easy to understand. And I think it's a great tool. It's great because it's simple. And if you set it up properly with the right metrics in it, it's a really great tool. But still, it's limited. Why? Basically, you only have 2 dimensions. Importance, forecastability. You can change it the way you want. It's only 2 dimensions. On top of that, you only have 2 thresholds per dimension, right? You just have A, B, C and X, Y, Z. It's not A, B, C, D, E, F, G, right? And these thresholds are somehow arbitrary. When you think about it, if you have a product here that's just right at the limit between A and B products, why shouldn't you just focus on it? If it's just 1% away of being an A product, maybe it's also worth spending your time on it, right? And these kind of things is where ABC will always be limited. Again, it's kind of a trade-off to do between, I want to have something that's really smart, but a bit complicated, or I want to have something that's robust and simple. We need to find the right trade-off for each supply chain. I'm not saying here that none of you should use it, but we can move forward. To move forward, we have to think again, what was the initial question? We want to spend our time on important products, and we want to spend your time where we can add value, right? So 2 things. Basically, if you want to move forward, you need to understand for each of these to answer all the very specific criteria of your own supply chain, right? So typically you could have a few products that are easy to forecast, but for which you have so much supply issue. Your supplier is always late, you have constraints, you have, I don't know, production issue and so on. You have delays because of shipment lack of shipments, and so on, right? So you need to spend more time on them. You could also spend more time on some product because of shelf life, because they can just get wasted, and you need to just focus on that. Some products are also maybe not worth so much money, but are critical for your business because of the deal you have with your client. So they're also worth spending attention to, okay? Finally, second question, where can I add value as a demand planner? Well, what about looking at promotion, new products, or just calling your clients, right? By doing this, you will also add value to your portfolio, even though you don't do that for these A products. If you know information on your client for a C mover, it might also add a lot of value to your forecast, right? It's not just about ABC XYZ. Okay. Let me ask you then a few questions on WooClap to see where you stand today. Let me start this question. You can already start answering it. Now, the idea basically, if you want to represent yourself in a maturity level, is we start at 0, where you would say, I don't have ABC, I don't do anything special, everything is manual. If I work on my forecast, I'm just gonna go for it and think about any product I have on top of my mind. The next idea is, no, I'm using this ABC XYZ, but maybe I'm looking at historical sales rather than a forecast. Maybe I'm using COV because I cannot compute forecast error. Second stage is, no, I have ABC. I'm using some very smart KPIs. I'm looking at future forecast weighted by values. I'm looking at historical forecast errors, so I really know which product I should work on. Last stage would be this smart classification, where you take into account business criticality, your supplier, and so on. Well, I see that we already have 31 answers. That's great. Okay, so I see that for most of you, you started to use ABC XYZ, but you're not still fully satisfied with the metrics that you use, and you could improve it. I think that's great. That means that you just did the first step. It's just about trying to push it further and to improve analytics. Okay, and we have already a few people that are really leading the game here using some smart ABC. That's really great. I will give the microphone to Stefan in a minute. I just would like to finish with one last question for you. It's basically, what's your next step? I think it's very important that us as supply chain, we try to move ahead. We try to do better every month at every cycle. I'm thinking about all the demand planners here that are maybe thinking, well, I'm doing this review every month and it sounds like, yeah, that's a good idea. Maybe if I had a better classification tool, classification metrics, I could just work more efficiently. Oh, wow, that's amazing. When I set up this question, I was really curious to see what would people want to do. And I see that a lot of you are actually already thinking, hey, I even want to go beyond ABC and I want to have this smart classification. I think that's great. I was not expecting this. You know, when I set up this webinar, I received a few mails from people saying, hey, Nicolas, you know what, ABC, I kind of love it. It's simple. I think it's just about improving it a bit and people will just like it. And I see when I ask you this question that a lot of you are already asking, like, but can we even go further? That's great. That's great. One last comment on this. Actually, this is the kind of idea that I've been setting up in some of my projects recently. When we develop some models, I'm trying to give a 5-star ratings to the models, saying, hey, you should really review this product, or no, this product, it's really just going fine. And basically the tool would assess if the user should review the product or not, based on, do we have enough data? Was supplier reliable in the past? Is this a new product, and so on. So this is the kind of idea you can have if you want to improve your classification. Okay, I will let the floor to Stefan now for a quick demo, and then we will answer your question. I will take the time to read them as Stefan is doing the presentation. Stefan, let me put you.
Can you hear me?
There you go.
Okay, so let me share my screen then. Okay, so you can see, only you should see my screen. Is that okay?
Yeah, we do.
Okay, cool. Okay, so first, I'm as you can see, I'm logged to the tool, to the platform, and my account is empty, right? So I don't have any particular information. So basically, if you open an account, you'll be exactly in the same state. So what I'm going to do for the sake of this demonstration, I'm going to upload a file. So just like any regular user. So I will select the file, and this file actually contains, so first the tool starts to analyze the file. So it's a basic CSV or Excel spreadsheet. Automatically, as you can see, my file is kind of basics. It contains some, 99 articles. They have some unit price associated to them, so a cost and a resale price. And plus, we have some data, basically 3 years and a half. Okay, so from January 2018 up to May 2021. Okay. So the tool automatically detects the format of the dates and also the quantity format. So for the numbers, since you may have different format depending on where you're located on the geo, and then automatically there is a mapping of my file with the field defined in the SKU Science platform. Okay, so no big deal here. I just need to select the forecast level. So for the sake of this demonstration, it will be the simplest one. So just the part number. So we will compute automatically the forecast at the item level. And here you have a summary table, okay, just summarizing what kind of information we'll put in the tool. So you can check that this is my file. And as you can see, I will activate this compute KPI information because based on what Nicolas shared with us, we need to get some forecast error at one point to be able to compute some data. And also this is why I've added some financial data in my file in order to be able also to compute and see, to project some revenue. Okay, so why I'm clicking confirm to start the upload of the file, and the computation of the KPI, I'm going to explain what the tool is doing under the hood. So this is actually the file. Oops, normally you should see it. So, and as you can see, there is as I said, there is let me check. I cannot access my bar here. Okay. So as you can see, there is some dates at the top, and what the tool is doing in the background is it will compute for the 12 last period. It will run 12 forecasts in a row. So basically, from May 2020, it will launch a first forecast, and then from June, it will add the June data, launch another forecast, and it will do this for the 12 last period in order for us to get 12 archive for this forecast. Plus, it will run the current one based on the latest data. Okay. So if we go back to the tool, but just before I do that, just to make sure everyone understands what's going on. So you can see, for example, for February, we'll have the data from January. We'll compute the first forecast for the next period up to June or even later. Then it will run forecast for March automatically with the data from February. Same for April with the data from March. And hence we will get 12 forecasts computed automatically and archived in the tool. Okay. So if I'm going back to the tool, we can see that the process is over. And if I log into the tool, I can see that I have 99 items that has been automatically uploaded based on the Excel spreadsheet. And you see that I already have some ABC computation and XYZ computation for every single element. So, and if I click on one item, you can see that the blue dots are actually the file, the data coming from my file. And as you can see, the tool automatically picks the forecast for every single item. And you can check visually that actually with the blue dotted line, that actually how it compares to the historical data. Okay, so you can see quickly whether or not it's very well aligned with the historical data. And you can see that I have this type of information for every single item of my file. Okay. So as I mentioned to you, we have some archives. So you can see also that, for example, in order for you to better understand what has been done during the upload. So if I decide to see this forecast that has been computed from May 2020, okay. So we use this last data and the tool automatically computed this information. But now that we have the real data, it's kind of easy to understand what was the forecast accuracy or the forecast error for this particular item, since we have all the data that has been computed. And as you can see, we have this table, which is actually automatically computed, and from which we can extract since we have the real data now, the real demand, and we have some forecast, we can compute for each single element the forecast error, which is here. And here we have the average, the 12% for lag free. Okay, so this is one example. Just to make sure you understand the concept of lag, I will come back later on to it to explain what the tool is able to perform. But as you've seen, okay, and as Nicolas mentioned, we have by default some rules that he described as the bad practices to do this ABC XYZ classification. But here, if we check, how we computed the ABC classes, so we compute them based on units, based on historical data, and we have taken the free last period, okay, to compute them. And so we have defined the limits 75% to be it's an A product, and if the B are between 75 to 90, and if you are above 90%, you are actually a C class, okay? And for the XYZ class, similarly, we are using the standard deviation, so the COV that Nicolas described, and we have set a limit for the X class to 20%, and we start the Z class after 40%, okay? So I hope this is clear. So now, just to show you that we have automatically computed this matrix based on these settings. So as you can see, we are based on volume, so it's really about the units, and we have the strong variation or some or little based on what is the COV for this particular XYZ class, okay? So if you go above this particular matrix, you'll see for each section that, so these one are probably the most important, okay? The AZ, because these are, if we focus on units, actually they are the one with the highest volume, but based on the coefficient of variation, it seems that there is a lot of variation in these items. So if we click on them, we'll see the list of these 5 items, and we can check quickly. As you can see, there is a lot of variation, and as Nicolas mentioned, we can see that really this is only based on historical data, but at least you can see really how the tool, and based on those class computation, why we get this particular item in this particular category, okay? So this is one way to do it. This is the one that Nicolas does not advocate to do. So now I'm going to show you first that we can change for the ABC class. So instead of computing on the units, so he recommends to focus on the revenue. So if we select the price, and instead of selecting the history, we should select the forecast, okay? So here we'll pick the free next period for the forecast for all to compute the ABC class. So if I click on save, okay, so the tool is just updating this, this data, and you can see already that just based on this revenue, okay, we have changed the matrix, and we have a different classification just for the ABC, okay? So these are the A products, the B are here, and this is the line for the C product, okay? So just by changing this, and now if we go back to the settings of the XYZ and apply the last recommendation from Nicolas, which is not using the standard deviation, but the forecast error instead. So here also we can set, as you can see here, the notion of lag. So just to make sure we all understand what this means, I'm going back to this slide, okay? So where we have all our forecasts, okay? February, March, April, May till July, with all this data. And if we decide, for example, to focus on lag number 2, basically this is a focus on the lead time, because when we create forecasts, we want to improve them. This is to do some, to improve our operation, and in particular, this is related to your lead time and how long it will take to get your raw material or to get the product that you will resell. So if you have a 2 months lead time, you want to make sure you will improve your forecast 2 months for this 2 months, I would say, period in advance. And here, this is exactly what this chart is about. Okay, so you see that the lag 2 actually forecast is comparing, like, for example, 65 to 70 in June, okay, 48 to 60 in May, and 51, the data from May that we have, actually 51 to the data from April, which is 45, okay? So this is really how this forecast data are actually extracted from all the archives of the forecast, and based on this, we're able to compute the error between the real data, which is 51, against the 45, which is here, okay? So if we go back to the tool, so if I select the forecast, the lag free, for example, which means I have a 3 months lead time, and I really want to focus my forecast error on this 3 months lead time. So I just need to save this information, and automatically the tool recompute all this classification. And as you can see now, I just have one item remaining here in this section, and we move from so first we move from volume to revenue. Okay, now we are focusing on revenue, and here this is really about the forecast error. So if we click on this one, on this item, we can see still, well, of course, there is a lot of deviation, but you can get directly, the estimation of the forecast error, which is 54 in this case. And because of the revenue which is associated to this particular product, this is really something. If we can save, let's say even 2%, forecast error, clearly you should see some savings in terms of revenue. So this is really one way to move, and to get this forecast computation. So this is one implementation, just to demonstrate, that the kind of possibility that it can give you in order to analyze, especially if you have many products. Okay, so you can see quickly that for this 99, actually this collection of 99 items, basically we have roughly 21 or 20 that we need to focus on, and the rest, are of less interest because they are not really impacting your business. Okay, you see basically 70 items that are not so relevant for your business. So really you should focus on this one, and based on how the forecast and the revenue that you are projecting in the next 3 months, and based on the forecast error that you are able to compute, if you recorded your forecast, you're able to get this data very, very quickly, and you can access this particular list, you see, and really start discussing with all your stakeholders and make sure that you can improve your forecast for the next round of forecasting.
Okay, thank you, Stéphane, for the demo. I propose that we spend the next 5 minutes or a bit more, if you have more time in the audience, for question and answer. I already received some question from Jean-Michel Meyer as well as Marco Badistuta. I hope I pronounced that well. Let me try to answer that properly. Stéphane, would you mind stop sharing your screen so I can show back the presentation? In the meantime, if you have more questions, feel free to wait, I need to be back to presentation role. How do I, Stéphane, can you promote me to presentation? Yeah, no, not yet. Well, as Stéphane is trying to give me the presentation role again, I would like to quickly then answer the first question, which is, could we use COV if we try to remove seasonality? Let me try to go back quickly to the question of, should we use COV to assess forecastability? For me, COV really has a few issues. First, COV is not your forecast. So if the question is, which product should you spend time on? And the answer is, we should spend time on product that we had difficulties to forecast. I would just simply advise you, but then why don't we just right away select product for which we had a high forecast error? That's just the straight answer to the question, which product are we bad at forecasting? Well, let's just select product for which we are not doing good forecast. If you move to COV already, you're just simply not answering the question, you're answering something else, right? Now, you could try to remove seasonality before computing COV, but then, sorry for that, you still have a major data leakage error. So basically, if you do that, it would be the same kind of thing. It would be like, here's 2021, you can try to assess on your own the seasonality of it, and then you can try to assess the variability in this. But then again, it's a data leakage, because when you forecast, you do not see 2021. You need to forecast 2021 based on 2020. Again, COV and removing seasonality of 2021 is you're doing this after the fact. So you're kind of overfitting to 2021, and it's very easy to forecast something once you see it. So again, COV is not forecasting. COV use data leakage. Removing seasonality is adding more complexity to your model. So you lose this kind of, yeah, but COV is very simple. As soon as you go into, I'm going to remove seasonality, well, it's not that simple anymore. You're also struggling with trend. But the most important is, let's go back to the initial question. The initial question is, let me go back to this initial slide. which product I'm the worst at forecasting and on which product I should spend time. Let's just simply answer this question. The product for which you're the worst at forecasting are those products for which you had the highest forecast error. Now, answering another question from one of you saying, yeah, but we don't have a forecast for all of our products. If you don't have a forecast, I would say then your maturity level is not yet going for ABC XYZ. What you need to have is a forecast engine that's able to populate a forecast for everything. Even if that's really basic, like a moving average of the last 3 months, that's fair enough, that's good enough. But it means that for you, it's too early to move on to, let's try to do ABC XYZ to kind of see what's important, because you don't even have a forecast. So you should start by having a process where you have this kind of forecast engine. Usually it's not that difficult. It is only difficult if you try to do that from Excel. Excel is not the tool to do massive forecasts, so don't try to do that from Excel. But actually, as Stefan shown on, like, for example, SKU Science, but other software as well, obviously, you can just load your data set online on SKU Science and you get a forecast within 10 or 15 minutes maximum, and you get ABC XYZ at the same time. Let me take a look at the other kind of question, and I'll be back to it. Someone was asking if we were going to get the recording of the webinar. Yes, we should have the recording of the webinar. I will send that right after. Is there, do you have some other question for me? Someone was asking, how do we measure bias? That's a very KPI-oriented question, but I'm going to try to answer that very quickly. It's very important actually to track bias in supply chain. Bias is the over tendency you have to over forecast or under forecast demand. So if, let's say, over time you always forecast too much or you always forecast too little, at some point you get bias. And usually, and this is what we see, if you realize that you have positive and negative bias in your forecast, it might be that you have some political issue, like some teams want the forecast to be very high to be on the safe side, or some team want the forecast to be very low so they can beat it. So basically, if you're biased, it might be that you have some political issue, especially with the sales team or finance people, but not always. Okay, would you have another question for me or for Stefan? Anyway, I said when I introduce myself, you can always feel free to send me an email with your question. I always love to discuss that, so that's for sure. We have another question here. Let me answer this one and then maybe a last one, and we stop here because I want to stick on ABC XYZ and not to move too far away on other forecasting subject. Let me answer the question from Young, and the question is, if I have a whole portfolio with thousands of SKU, how do I know which method to use? Usually what I advise to do, and that's what we do at SKU Science, this is what I'm advising in my book, and if you buy the book, you get the code to do that, is you do not know when you get a product which method is the best, right? So basically what you need to do is to try out multiple techniques, try them out on every single product, and then keep the best one. And that's how you do it, basically. You don't try to first just try to assume these products are going to get this technique, this product going to get this technique. No, you try out a lot of techniques on different products, and then you keep the best one. Okay, again, you can easily do this in Python, for example, as I show in my book, but if you try to do that in Excel, you will really have a lot of difficulties. And I think that's the main issue for supply chain, is that a lot of people just try to fit it in Excel. And once you have even 150 products, doing it in Excel is quite difficult. Okay, looking at time, we are a few minutes ahead. I got here a question from Irtian. How do you do ABC XYZ with double ABC reporting? I am not familiar with double ABC reporting, Irtian. Maybe you would have more information here. Again, in general, these ideas where you say, we go from ABC XYZ, but then we add 4 dimensions here, another dimension there, and then we add a third classification like ABC XYZ 1, 2, 3. Then basically complexity is growing, growing, and growing. And then what I would advise you to do is basically just to say that you want to move on to the next maturity level. And then what you want to have is a smart multi-criteria segmentation where you say, okay, but let's also take into account shelf life, supply reliability, a new product, and so on, and I would move out of ABC XYZ. The great thing about ABC XYZ is it's straightforward, it is simple to understand, and that's great. But if you want to face more complexity, adding more dimension, you will lose this simplicity aspect, and I would advise you to move on to another tool. Okay, perfect, everyone. It was a pleasure to have you on board for this webinar. I will soon close the recording. Just a last question here from Durvesh, and is asking, is it realistic to have price and value constant? In most of supply chain, cost and price will be relatively constant. Obviously, you cannot have price and cost constant over years, but over the next few months, it might be realistic. Even if it changed by a few %, it should be fine. So people, it was a pleasure for me to share this presentation with you. I hope you enjoy it. I hope you will find it helpful. It's always a pleasure for me to discuss that with you, obviously. And then I guess I can tell you, see you later on LinkedIn.